Hello friends, in the previous module we have seen some basics of 8086 microprocessor such as its block diagram, its pin diagram, its working, its machine cycle, its T state, its interrupts. Now we are going to see how to write the program for 8086 microprocessor. Now whenever 8086 microprocessor tells us something, we have to see that how the 8086 microprocessor works. So for that we have seen the T1, T2, T3 state. But whenever we have to tell something instruction to the microprocessor, we have to write in the some instruction format. So basically, first of all, we should know that since 8086 microprocessor is a digital device, it knows only the language of ones and zero, that is digital language. So but user cannot able to remember all the digital signals which are to be sent to the 8086 microprocessor. So that digital language we normally called as machine code, but always user is not able to remember that all the instruction in the digital mode. So the user defined assembly language is used for 8086 microprocessor, that is called as assembly language instruction. So for writing the assembly language program, we should know how to write the assembly language instruction. Now we will see first of all the format for assembly language instruction. Now assembly language instruction consisting of some fields, namely firstly is label field, which can be also named as address. The second is nothing but opcode, and the third one is operand. Now these are the main three fields of any assembly language instruction. Now what are the significance of these three fields? So firstly, the instruction is written in the memory and it is to be written in some address. So that address is being defined in this first field, namely label or address. So if we signify the address, we can signify the address as just like 20001000. So in this case, the first address is segment address and the second address is offset address. So by combination of these two addresses, we form a 20-bit physical address where the actual instruction will be written. Now the second is nothing but the opcode. Opcode stands for operation code, which signifies what operation do we perform by the instruction. So for example, we will take a opcode for the instruction is add. This ADD opcode signifies we have to perform addition with the help of this instruction. So add is nothing but a mnemonic for addition operation. And next is nothing but the operand. Operand means on what part of the architecture we have to perform, whether we have to perform this addition on data, or whether we have to perform this addition on the memory, or whether we have to perform this addition on the register. So depending upon that, operands can be defined. So for example, I will take the operand as AX and BX register. So now the operands are AX and BX register, so the addition will be performed on this AX and BX register. So the combination of this label, opcode and operand field forms a assembly language instruction. Now one more thing we have to say about this is nothing but, in this case we can see there are two operands. The first is nothing but the AX register and the second is nothing but the BX register. Now in this operand also, the operands are being defined on two bases. The first one is source. In this case our BX register is source and AX register is destination. Means the operation will be stored in the destination, that is BX register, and the source of that operation will be from BX register. Now we will, in the case of actual instruction set, we will see how the operation is actually performed and from where the data is forwarded to the destination. So this is first of all the case of assembly language instruction and how we can write the instruction. Now next thing which we are going to see is nothing but the addressing mode of 8086. Now addressing mode means the operation which is being performed, that can be performed on the register or the memory or the immediate value. So depending upon what we are providing in the source field of this instruction, that will signify addressing mode of 8086 microprocessor. So now depending upon this, there are number of types of addressing mode can be defined, and we will discuss that addressing mode of 8086 microprocessor. So first addressing mode is immediate addressing mode. Now immediate means the operand which we are specifying is immediately available after instruction itself. Now what do you mean by immediately is the instruction which we have written in the assembly language will be converted into machine code, and after that machine code the operand will be available immediately after that. So that is nothing but for immediate addressing mode. For example, we can take it as a move AX, 0000 H. So move is nothing but our opcode. MOV stand for moving the contents. AX is one of the operand which is destination in our case, and 0000 is our second operand which is source, and H stand for it is a hexadecimal value. Now in this case, this operand which is the second operand is immediately available after the instruction. So that's why it is a immediate addressing mode. So like that we can write number of instruction add AL, 07. So in this case we have taken 8-bit operand. In the first case we have taken the 16-bit operand. Depending upon the instruction and depending upon the operation which we have to perform, we can have the number of different instruction can be written for the immediate addressing mode. Now second addressing mode which we are going to see is register addressing mode. Now as the name signifies, the operand which is specified in this addressing mode will be of register. So I will write directly the instruction, and I will take the same opcode which I have taken for this first example, that is move. Let's say first operand is AX and the second operand is CX register. Now in this instruction what we have written is move, that is copy the data from one of the register to the second register, and for that the registers which we have used is nothing but AX and CX. So one register is AX and second register is CX. Now in this case you can see that the second operand which you have specified is nothing but a register. So that's why it is called as register addressing mode. Now what operation performed in this addressing mode is contents of this source register is copied to the contents of the second destination register. Similarly I can write like this, move BL, which is nothing but the destination in our case, and CL. So this is the example for 8-bit data transfer using register addressing mode. Third addressing mode is where the operand is specified in the memory. So we can broadly call it as a memory addressing mode. In memory addressing mode, for example, if I take move AX, now for specifying the memory the square brackets are used, and depending upon how we are specifying the address of that respective memory, the different number of memory addressing modes can be divided. So we will see the detailed view of this memory addressing mode. So in this memory addressing mode, the first is direct addressing mode. In direct addressing mode, the address of the operand is directly specified in this address. So I will take the example move AX in bracket 100H. Now this is the address which is specified directly in the brackets in the instruction itself. So the contents of the address 1000H will be copied to the AX register. So since the address is directly specified in the instruction itself, it is called as direct addressing mode. Now we have seen that physical address consists of 20 bit and we have two types of addresses, that is segment address and offset address. Now which is this 16-bit address? So first of all we have to select the segment address only, and for all the other operations the segment address will be fixed, and for specifying the each location we are providing this address of offset address. So always in memory addressing mode, whatever the address specified over here will be of offset of that respective segment. Now next type of the addressing mode in the memory we will see. Second type in this addressing mode is indirect register addressing mode. Now in the previous case we have seen address is directly specified in the instruction. In this addressing mode, the address is indirectly specified by using some other register. So if I return move AX in bracket CX, now in this indirect addressing mode the address is not directly available, it is available in the other register which used for specifying that address. So in this case what will happen, if the contents of CX is 2000, so this is nothing but the address which will be specified in the instruction. So what will happen in this case is, so for example I'll take the segment address as a, let's say 1000, and the CX carries 2000H. So the combination of 1000 and 2000, now this is the second address, and something value will be available in the memory. That memory value will be forwarded to the AX register. So this is what happens in the indirect addressing mode. So indirect addressing mode is used for specifying the address by using some another register. Now third type of addressing mode is indexed addressing mode. Now it is also the memory addressing mode itself. Now in the indirect register addressing mode we have seen the register is specified for specifying the address. Now in the case of index addressing mode, the indirect register which is being used, that is a index register. Now for example I have taken SI, that is source index. So whenever we are providing the index register for locating some address, that is called as index addressing mode. So this is one of the example of index addressing mode, and where the address will be stored, address is stored in the SI, and from that address the contents will be copied to the AX register. Fourth is register relative addressing mode. Now in offset address, if we know that something string we need to specify, and in that string we may know the location of that respective data. So if we wanted to know the location of the data and one of the starting address we know, we use the register relative addressing mode. So in register relative addressing mode, the instruction will be specified as move AX in bracket 20H and BX in bracket BX. So in this case of register relative addressing mode, the actual address is being found by the contents of BX plus this 20, which is nothing but the relative to that. So for example, if I had taken the contents of BX is, let's say 1111, and the relative address is 20, so that 20 will be added to this. So 1131 will be the new address from where the contents will be forwarded to the AX register. So this is the register relative addressing mode. So relative to this BX, 20 locations are being considered, and from that the contents will be forwarded to the AX register. Now the next is base index addressing mode. Now in base index addressing mode, for specifying the address of memory two registers are used. Firstly is nothing but the base register, and the secondly is nothing but the index register. So I can write the instruction as move AX in bracket BX and SI. So now in this case, the first register is base register, that is BX, and the second is nothing but the SI. Now how the memory address is being formed over here? So the memory address for this base index addressing mode is formed by contents of adding base register, that is BX and SI. So which will form a new address from where the contents are being fetched. So in the starting lectures we have seen some special case of registers. So we call the other AX register as a accumulator, BX register as a base register, CX register as a counter register. So since the BX register is called as base register, we can use this BX register over here. So for example, if I had taken the BX as a value as 1000 and SI value as a 3000, so the combination of this is nothing but 1000 plus 3000 will be 4000, from where the actual data will be forwarded. Next is base indexed relative addressing mode. Now in base index register addressing mode, the address can be formed by base register plus index register and relative to some value. So I can write like this: move AX 30H BX and DI. So we know that one of the index register is destination index also. So in this case I have taken the BX register and DI, that is destination index, and added the 30 value relative to that, and from this all the three values the new address is being formed of the memory from where the actual data will be fetched. So the contents of the memory which is being found by adding the contents of BX plus DI plus 30 will be forwarded to the AX register. So this is the base index addressing mode. Next addressing mode is branch addressing mode. Basically branch addressing mode deals with the different types of instruction which are used for changing the sequence of the program. Now most of the programs are written sequentially, but some programs need to change the sequence of the program. So let's say from 1000H location we need to change the location to the 2000H. So for that purpose some instruction named as jump instruction is used. So that comes under the different branch addressing mode. Now in branch addressing mode there is different types of branching required. So firstly is nothing but intra-segment direct. Now intra-segment direct means the sequence of the program change in the segment itself. So whenever there is no change in the segment after the changing the sequence of the program, it comes under the intra-segment direct. Now the mnemonic for jump instruction is JMP, and when we are providing the direct address to that, that is short label we can provide. Now for demonstration purpose we can show like this, that if this is the memory addresses which we are providing, and let's say one of the segment is specified, and let's say that segment address is starting from 1000H and the segment address is let's say 2000 and 1000 as a offset address. So if the current instruction is at 1000 and we don't need to change the contents of segment address, we just need to change the contents of this offset address. So this jump instruction can be used, that is named as jump short label, which will change the execution of program from 1000 to any location which will be provided by the jump. Okay. So this short signifies that the jump is between the branch addressing itself, or it is in the segment itself. So this is the one of the example for intra-segment direct. Now in the segment itself we can use any other register for providing the address. So that comes under the intra-segment indirect. Now in this jump short label we provided the label or address itself in the instruction. So if we don't wanted to provide that address directly, we can provide it by using some other register. So for that purpose, we can write the instruction as JMP in bracket CX. Now this CX contains is nothing but the contents of some memory where the actual address will be available. So contents of CX will be nothing but the new address where we need to change the sequence of the program. So this is the intra-segment indirect. Again, the segment is not changed in the intra-segment indirect also. So the sequence of the program change in between the segments. Next, two types of inter-segment direct and inter-segment indirect. Now in inter-segment, as the name indicates, we need to change the sequence of the program from one location to the another location, and the other location will be available in the second segment. Now for example, I'll say the second segment start from 2010. So this is the segment address of the second segment, and let's say in that segment I need to change the execution to the 0100. So in that case, the inter-segment direct can be written as JMP 2000 bracket 0100. So here we are directly specifying the address where we need to change the sequence of the program, and that is called as inter-segment direct. Next addressing mode in branch addressing mode is inter-segment indirect. Inter-segment signifies the sequence of the program is changed from one segment to the another segment, but the address is provided in the inter-segment indirect is through some register. So if I have written JMP in bracket BX, and in this case the jump is long jump signifies that it is changing the sequence of the program and it is also changing the segments. So in inter-segment indirect, the jump is happen, but the address of the new addressing mode is available in the another register. So this is called as inter-segment indirect addressing mode. Now lastly, the one addressing mode is nothing but the string addressing mode. Now in all the addressing mode which we have seen that how the operands are being specified. In some cases it is immediate, in some cases through register, in some cases some memory, and in the branch addressing mode by using direct and indirect. Now in string addressing mode, the operands are being by default available in the instruction itself. Now string addressing mode is nothing but a special feature of 8086 microprocessor in which the number of memory locations are being accessed. So for example, let's say we need to perform some operation on the 1, 2, 3, 4 locations simultaneously. So and I need to transfer the data of all the location from one memory location to the second. So I need some instruction which will be work on this all the 4 address from one memory to the second memory. Let's say I'll name it as memory 1 and memory 2. So in this case, whatever the instructions used for providing the address through number of consecutive memory location, we call it as a string addressing mode. So one of the example for string addressing mode is MOVSB, that stands for move string byte. So in this case, the source operand address we know the destination operand address, and depending upon the count value stored in CX register, that many contents of the memory 1 will be copied to the memory 2. And in this case, now where the operand comes, the operand over here is nothing but the combination of DS and SI, that is data segment register and source index, and ES and DI, that is extra segment register and DI. So it will form one address, that is nothing but a source address, and it will form a second address, that is called as destination address. So the data is starting from source and it will be forwarded to the destination, and the address will be formed by these two addresses. So in string addressing mode, we can say that the operands are data segment register and source index, and extra segment register and destination index. So in this lecture we have seen the different types of addressing mode, namely immediate addressing mode, register addressing mode, different memory addressing mode, branching addressing mode, and lastly string addressing mode. Thank you.